Hi everyone, this is Mrs. Jackson. This is Chapter 2, Section 6, Part 1. In this video, we are going to derive the quadratic formula. So up until now, in this chapter, we've been solving quadratic equations, looking for those x-intercepts using two different methods. The first is factoring, which works great if those solutions are real and rational. However, factoring is limited if those solutions are either irrational or if the solutions are complex. And so then we learned our second technique, which is called completing the square. And if we apply the same technique of completing a square on a generalized quadratic equation, then we can create a formula. And that formula can be used to find those x-intercepts or zeros for any types of solutions. So let's take a look at how we can derive that formula. So here we are starting out with a generalized quadratic equation. ax squared plus bx plus c equals 0. This equals 0 because we're putting that y in our function equal to 0, and by doing so we're going to solve for the x-intercepts or the zeros. Now if you recall, a is just a placeholder variable that we use for the coefficient in front of the x squared term. B is also a coefficient that we use in front of the x term, and C is just a pure number or a constant. All right, so let's go ahead and start applying the complete the square on this generalized equation. If you recall in the last section, I had said that it's much easier to make a perfect square when this coefficient here is 1. And so the first thing we're going to do is we are going to divide everything through by that coefficient. And when doing so, I'm going to end up with, I'm going to put it over here to the left, x squared. In other words, a divided by a reduces to 1 plus b over a x plus c over a. And on the right side, 0 divided by a, 0 divided by anything is 0. All right, if you recall, to complete the square, we want to get this constant term out of there, because on this left side, we're going to try to make a perfect square where 1 doesn't exist. So I'm going to go ahead and subtract c over a from the left side of the equation, and if I do that on the left, I have to also do that on the right. And what we have left is x squared plus b over a x equals negative c over a. Okay, so I want to create a perfect square over here on the left. I'm going to add something over here to create a perfect square, and whatever I add on the left, I'm going to have to also add on the right. If you recall, in order to find this c here, this term that's going to create a perfect square, we divide. So I'm going to write that down and just remind you, c equals half of b squared. In this case, our b is not just b. Our b is b over a. If I divide b over a by 2, in other words, take half of it, and then square that, I'm going to end up with my term here that's going to create a perfect square. b over a divided by 2 is just b over 2a. And then when I square that, I get b squared over 4a squared. In other words, I'm squaring the numerator as well as the denominator. So that is the term that I want to add to both sides here. So I'm going to add b squared over 4a squared to the left. And if I do that to the left, I'm going to have to add the same exact thing over here on the right. Okay, so how do I write this perfect square? Well, remember that this half of b here, this half of b, in other words, b over 2a, that's going to be these two terms here inside those parentheses that when multiplied by itself gives you this c. So I'm going to rewrite this as x plus b over 2a times x plus b over 2a. If I multiplied everything out and distributed everything, I'm going to end up with, right back here where I started from, x squared plus b over a x plus b squared over 4a squared. So I've got x plus b over 2a squared now. It's a perfect square on the left. Over here on the right, I see I have somewhat of a common denominator, so I'm going to go ahead and combine these. The greatest common denominator that I can use between these two terms is 4a squared. If I look at 4a squared divided by a, I get 4a. So I'm going to go ahead and multiply that by my negative c here. So I've got negative 4ac, and I've got plus b squared, and I'm going to go ahead and combine that. It's a little bit awkward to have this negative 4ac plus b squared, so I'm just going to rearrange the furniture there a little bit and just write that as b squared minus 4ac over 4a squared. All right, great. I now have a perfect square on the left side. The way I undo a perfect square is the square root. Inverse operation of squaring is the square root. So I'm ready to take the square root of the left, and if I do that on the left side, I've got to do that on the right side. Notice I'm making very large radicals here so that you can see it's taking the square root of everything over there on the right. All right, what comes out on the left is our x plus b over 2a. So in other words, the square root here undoes the square, inverse operation. So whatever inside that radical just comes out. On the right side here, if I take a square root of a big fraction like that, that's the same thing as taking the square root of the numerator. And I can take the square root of the denominator. Now, why am I doing that? Because I've already spotted that that denominator is a perfect square, so I might as well simplify my life here. All right, on the left, I have x plus b over 2a. On the right, I have the square root of b squared minus 4ac. And I'm going to go ahead and take the square root of 4a squared. And don't forget, I get the positive and the negative. So the square root of that is positive and negative 2a. Okay, I'm getting very close here. I'm going to continue to isolate my x term by getting this b over 2a out of there. If I subtract that from the left, I have to subtract that from the right for equality purposes. So on the left, I have x equals negative, and on the right, I have negative b over 2a. This right here in the denominator kind of looks like a sign, right? Positive and negative 2a. I'm going to move it up and use that sign to represent operations, plus or minus. And then I've got the square root of b squared minus 4ac over 2a. And then the reason why I did that is because I now see that I have a common denominator. So I can go ahead and add these, combine these fractions here. And what I have is opposite of b, or negative b, plus or minus the square root of b squared minus 4ac all over 2a. And that is the quadratic formula. So whether you have zeros or x-intercepts that are real rational or real irrational, or complex, you can use this generalized formula over and over again and find those solutions. So by simply knowing your A coefficient, your B coefficient, and your C constant term of any quadratic equation, you can use this formula to find the solutions. It's a complicated formula, and it usually is not given on reference sheets for the SATs or anything like that. There are hundreds of videos on YouTube that help you try to memorize this formula by putting it to different songs. So you could Google that and see if any of those work for you. Okay, I hope this video helps. Quadratic formula. Thanks for listening.